Hello, everyone. It's great to be here. My name is Adam Flanders, and I'm a technical manager of development operations and projects at the University of California Office of the President. To start, we are by no means experts of event-driven architecture. However, our environment is a little different, and I'm hoping that our experience can provide some help to others who are just beginning this exciting transformation. Others a little further along, at the very least, should have takeaways from some of our lessons learned. So let's get started. So to start, the University of California is a state university system with campuses spread all throughout the state of California. This consists of 10 campuses with over 250,000 applications for admission that were received last year. Just under 300,000 students are actively enrolled. 227,000 plus faculty and staff, over 15,500 acres between all of the campuses, 2 million alumni that are available globally with over 800 degree programs and 71 Nobel Prizes awarded to the faculty. Other institutions include extension campuses, agriculture and resources, natural reserve system, 5 medical centers, 3 national labs, and 2 observatories. So it's a very big system. So we are a public university funded by public dollars. That means that UC not only functions in the academic sector, but also the public sector as well. With that academic mission comes additional public mandates, things like, and those typically come with challenges that do apply to our organization. Things like high governance culture, which is very risk-oriented, siloed expertise, which is actually the dominant form of management in an organization. That in turn brings limited visibility, limited resources, given even with these wide missions that they have to accomplish. And of course, a key differentiator is that money is rarely an output, unlike the corporate sector, but a consumed asset. The cross-campus enrollment system that we actually developed was a collaborative system with campuses and the Office of the President. Each campus brought their own expertise with their technology stack and ecosystems into the project, an international space station program for UC, if you will. The purpose was to seamlessly allow UC students to take other courses online offered at other UC campuses and help students get access to courses that may have been overbooked or unavailable. The main system, called the Hub, would function in the cloud between the campuses, but would have to talk with all of the campuses, despite their different technology stacks, architectures, and delivery patterns. I'll talk more about this shortly. The main system includes systems for enrollment, course selection, online seating and grading, and integrated each with the campus systems. Once this had been achieved, we then scaled the system to other partners like extension campuses, graduate schools, and other programs with commerce functionality, things like with payment gateways and added marketing and analytics services. We also continued to scale the platform using serverless computing like with AWS and Lambda. We then put Solus added as their services between our middleware and then also continue to add it as a second layer between our middleware and each of the campus systems. So we're currently in the process of doing that. Now, in order to overcome some of these typical challenges from both academic and public sectors, there were certain things that we found that worked very well. Number one was creating a culture of innovation, which typically used a lot of ground up actions followed by top down direction. There also had a lot of cross matrix teams that were involved with the project, where each of the members were bringing expertise in their own domains to then share with the common mission of the team. And then they would disseminate and share problems, not only centrally, say as the hub team, but all of the different campus functional teams that happened at all the campuses. We would often come together and talk about different cases, technologies, and these little symposiums or informal gatherings that we tend to call collabs, and then also shared open resources like wikis, API portals, monitoring dashboards, things like that. We also would decentralize operations and then encouraging things like self-service among our users and partners and personnel. And also we, constantly tried to consistently get together for new technologies, discussions, introducing and looking at new experiments and pilots, which we tended to call gardening at the campuses for these new approaches and patterns. From a tactical perspective, we also employed these following things, including going after the low-hanging fruit, utilizing more of a hybrid agile framework instead of the main agile framework, tended to work best within our environment. We had artifacts that typically were journey mapping and value stream mapping and portfolio management, along with dashboards and key performance indicators. We also integrated our security and did test-driven development. And then from a change management perspective, tried to do more of an omni-channel approach where we were trying actively to keep it really out of email as much as we could. And then stakeholder meetings were often conducted both on a formal and informal basis. So UC, like most organizations, has gone through its evolution in architecture and data. We've started with a federation of independent ecosystems that each serve either all of the campuses with their own unique technology stacks, delivery systems, and functional teams. These worked great to serve their own individual campuses, but unfortunately they resulted in lots of redundancies and didn't allow UC to leverage services across campuses effectively. Then some isolated UC teams began to use SOA to consolidate and leverage some efficiencies, but they required high capital investments to make these inroads. The CCES actually came in with more of a cloud-oriented approach and APIs, but it was designed more in large monoliths. It was hard using this type of architecture to visualize the data streams, and it also created tight coupling of processes. Many of the campuses were still on legacy systems as well, so they were utilizing on-premise, hybrid cloud systems, all kinds of different technology stacks. So in order to move the needling on decoupling these services, we, and to better enhance troubleshooting and the data streams, the hub team at UC then re-architected to a microservices architecture. And then of course, recently we've deployed an event-driven architecture, which I'll talk more about in just a few minutes. So there were several unique challenges that we actually had to overcome. The University of California has a tradition of shared governance, and that faculty do share in the responsibility for guiding the operation and management of the university. And while they do that, there is the authority of the university governing board. The regents actually does ultimately set the policy. So other than that challenge, there were also additional challenges, like that there was no universal ID between the UC campuses and no universal credit that was actually granted between these campuses as well, which is very unusual for a university. And then to add that, we had additional challenges as the system matured around two big themes, basically, growth and complexity. First, you can see here, year to year, our growth was actually growing over 50% each year over year. So it was happening very quickly. And then you could also see in the growth of our course catalogs, we started around 13 and then have already ended up around maybe 550 at this point. So with those two types of growth here, the complexity and all the students enrolling really, really increased. And that does lead us to that additional complexity in terms of the impacts. We were seeing systems falling out of sync. They were resulting in late and dropped enrollments. We had a risk of reporting increases that were inaccurate. And then we also had inaccurate resource management was becoming more prevalent. And then of course, with all of this, the technical debt was increasing as well. A few years back, Gartner published a graph illustrating the power of data and its life cycle. Data derives its power from its ability to be informative and actionable. Data also has an extremely short shelf life before going stale within minutes to hours. So it's essential to make the earliest possible use of data to adapt when change is needed and make our scaling complexity challenge happening all of that time. It became even more important and vital for us to do this. And then throw into the mix, we had the pandemic that arrived. That showed increased scenarios of burst handling that were already happening on a seasonal basis. Newly emerging data access changes were becoming more and more prevalent that were coming from the campuses, and we had to decipher those changes. And then we also had to add new disparate systems into the mix. So we didn't have that needed flexibility. Examples of that included rapid change in the processing requirements, regulatory and policy changes with personally identifiable information, new services that were coming on board with new trends and KPIs, and then of course the routing customizations that were needed for all of these different campuses for all their needed requirements. All of this, of course, meant that the technical debt was increasing dramatically. So what did we have? We have this point-to-point breakdown. This then added to our basic drivers and looking at event-driven architecture, where we needed to improve the application responsiveness, improve our application resiliency and availability. We needed to pay down that technical debt. Plus, we needed quicker agility around real-time changes. We needed to enhance our visibility and then ultimately, of course, improve user experiences. So how did we get there? And how do we determine events in an environment as large and heterogeneous as you see? Enrollment, of course, enrollment in graduation is all a common journey of every college student, and certainly within our program as well. Many of the campuses were still running various steps of enrollment to graduation as batch processes, point-to-point interactions, manual processes even sometimes. And of course, events are repeatable changes in the process to improve that overall experience between the students and the faculty. So things where a typical scenario might happen where would be a student applying for admission into the program, and then that would launch these different discrete processes of processing that application, approving that student into the program, enrolling that student into the different systems that they need to get access to in order to take their courses and get graded on those courses. So things like that, as well as other scenarios that were often common in our environment, like allowing a user to enroll in a certification program, somebody from outside attending, say, an extension course, and they have to get access to all of the required systems in order to attend that. And then you have a typical scenario that might happen where a student ends up signing up late for a class, and then they end up getting put on the wait list, and then again, when that change actually happens at the campus and those courses become available, that student can then move in, hopefully seamlessly, into that class. So changes are often happening where they're global in nature. They're across usually hybrid and multi-cloud environments. And of course, diverse technology systems we're utilizing with all the different campus systems that we have to talk to. We require that enterprise performance needed for this type of, to enhance the experience. And then it has to be simple, where we have these events that are designed, that are modular, and they're able to be reused and discovered, and as well as governing in terms of and maintenance as well. So that brings us into more on the event streaming and event management of EDA. In terms of impacts in our own environment, it's pretty universal. We have on the technical data side, we have on the academic organization side, and then we have the typical user experience impacts that can happen as well. So you can see all of these different, whether they're at the technical team end, whether they're dealing with just the data management and flow, storing in data lakes, and then student records management all the way from enrollment to graduation, versus data that is being managed, maintained actually and organized along a academic maintenance and operations level, where they're dealing with enrollment and resources management, seat capacity and logistics, and then of course digital classrooms. And then those individual users that actually need to be able to see those students and where they are in the flow. Registrars, advisors, alumni, students that are actually trying to validate and ensure that they are an actively enrolled student in order to get access. And of course, it's important for them to do that because the later they get into a course, their performance goes down dramatically because they have a lot to catch up on. So let's take a deeper level on, we'll take a deeper look at the typical event and the value that can actually be derived from that event in our environment. So when we took on this project, we had to understand the ecosystems and approaches of our campuses, especially since none of them were actually utilizing the cloud native architectures that we were. And a lot of them were bringing to the table some forms of really big legacy systems. So what that means is if we had a typical course change event, say for example, that we at the hub team would expose in our middleware with APIs in our ESB, we would then be notified of that change. Usually it was in a manual process, unfortunately. And then we would then be notified when that change was happening that we would have to pull that course from the campus that was actually changed. And then that would then launch some additional processes where the wait list or these students would then get seeded into these new classes when that event actually happened. So what is the value? So typically this is an event, but number one, it's not pushed. It's exposed as a combination of batch or ESB or even manual processes, as I was saying. It's non-real time. The downstream applications do not get to know immediately what the status of that student is until they ask. So often, they fall out of sync with each other. It's definitely not agile. So new downstream applications is difficult when they need to be added. It often requires programming teams and development interventions in order to get it running. And then we had a lot of serial processing that happens in terms of unwanted coupling, where all of these systems that would actually be put in place, if there was a failure further upstream, the whole process would stop. So the course changed event, looking at more from an event enabled pattern, was a little bit different when we were started implementing this approach. Instead, we would actually expose it again through our ESB and APIs, but a little bit more broadly over an event mesh, and then expose the course update event. We would then get real-time updates to the notifications about the course update event for these downstream processes. And then we would, once we received that, would then make a course catalog update back to the campus where that change, that recent course had been released. And then of course, once that was already in process, we knew that we would start provisioning, basically seating these students that were waiting in those wait lists to subscribe to that particular course that was adding seats. So again, the value of it's still the same event, but in this case, in this scenario, what we were seeing is that the status was already pushed. It was always pushed through a combination of the enterprise service bus and streaming processes. It was real time and responsive, where the downstream applications were just constantly listening for the change of that event in real time. It was agile, where we could easily add new downstream applications, and then those applications would then just need to listen to that event. So no enterprise service bus API changes were needed, no programming teams were needed, no downtimes as well. And then parallel processing was actually able to happen a lot faster, because the tight coupling that was introduced with that old paradigm actually would allow us, instead with the streaming of data, be able to process it even in parallel. So that overall better all scaling and better response times and experiences for ultimately the users. So there are some near-term applications at UC that they're looking at for further application of EDA, things like analytics, intelligent queuing and routing, and messaging as well. But because of time, I'm just going to focus more on the analytics piece and what that typically looks like and how we've addressed it. So with our analytics, there's 3 typical patterns that happen. There's the load and lake pattern, where we're batch process, we're loading with an ETL or ELT pipeline into that data lake. And then once it's in the data lake, there are pull APIs or queries made through GraphQL in that data lake to get those insights. And then eventually we want to push that data from in event streams out to other applications for them to be able to consume that needed data or even insights. All of that would be then exposed over the data, the API, the event portals, and catalog. So we did have some key moments here where I wanted to share in terms of lessons learned. We had big constraints existing over services using span teams, domains, and sites. This happens a lot, but you really need to take into account for that complexity right from the start. So I would just encourage you to understand more of those unacknowledged dependencies that are going to actually come into play. Because of that complexity, visibility is key as well. Another aha moment that we actually had was around capacity planning. When we were actually doing that, I would definitely recommend, in terms of complexity, that you account for that traffic being growing at a more of a geometric growth, not linear when first setting your thresholds. Things like message errors can really add up quickly, especially the more critical messages that may be coming across. So take that into account. Number 4, metrics do matter, of course. So when you're actually marching towards your key performance indicators, that ultimately determines your success. So choose those very carefully. And another aha moment was using regular time boxed retrospectives. Okay, but that doesn't seem very important, but it provided immeasurable value in overcoming near-term bias that we all typically have. We want to focus on just the short-term things. And that really kept us moving forward in terms of evolving the system. And then number 6, in terms of education, the metaverse really is there for future growth, opportunity, and solutions. So we're really invested in the possibilities there. I think with EDA, we are very much set up to take advantage of all of these new exciting future technologies that are happening, whether it's blockchain, AI, augmented reality, Internet of Things, and putting over a event mesh with event-driven architecture allows us to be ready for those inputs and outputs to utilize all these new technologies, which ultimately could mean things like automated records management, new forecasting and modeling, say around predictive analytics, optimization more on a dynamic basis around automated seats and provisioning around courses there. And then maybe even equipment tagging and library resource management and watching the flow of those types of assets going around the campus. So all of these are very exciting, and hopefully you got something that a little bit of some value out of what we had to share. So thank you again for having us here. Bye-bye.